Hi, welcome to FatMath. In this video, you will learn tangents and secants of a circle. If you haven't subscribed yet, please subscribe and watch the videos for grade 10 and other math subjects in your high school. So, tangents and secants of a circle. Tangent line to a circle is a line coplanar with a circle and touches it in exactly one point. And the point of tangency is the point on the circle that the tangent line touches. So here in this illustration, we have here circle O, and we have here a tangent line BC, and it touches circle O at point A. So this line BC is called the tangent line, and this point A is called the point of tangency. So as what you can see here, this circle is touched by the line at only one point, at exactly one point. So if a line touches the circle in exactly one point, then that line is called the tangent line to a circle. And then if you have another point here, you can also make another tangent line passing through the circle at this certain point. Okay, so this point is called the point of tangency. So how many tangent lines can be drawn at a given point on the circle? For example, we have a point here on the circle. How many lines can you make passing through this point? Okay, that touches the circle at only one point. So exactly one. So we can only make one line. So the tangent line to a circle at a point is unique. Okay, let's go to the theorems. Theorem number 1. If a line is tangent to a circle, then it is perpendicular to the radius drawn to the point of tangency. So if this line AB here is tangent to circle O, then it is perpendicular to radius AO. And another, if a line is perpendicular, if this line is perpendicular to this radius here, at the end point at A here, then the line is tangent to the circle. So the first theorem states that if the line is tangent, then it is perpendicular. The second one is if it's perpendicular, then it's a tangent. So, okay, let us have an example for that. Line AB is tangent to circle O at point A. If OA, this one here, this radius, is 6 units, and OB is 10, what is the length of AB? So as what we can see here, they form a right triangle, and 10 is the hypotenuse, and this OA is one of the legs. So since these are sides of a right triangle, then we will use the Pythagorean theorem that states that the sum of the squares of the two legs of a right triangle is equal to the square of the hypotenuse. So the two legs here are AO or OA and AB. So the sum of their squares is equal to the square of OB because this will be the hypotenuse. So we know OA, which is 6. So let's substitute it there. And OB is 10. And we will solve for AB. So 6 squared plus AB squared equals 10 squared. 6 squared is 36. Copy AB squared. And 10 squared is 100. Since we are solving for AB squared, we will add negative 36 to both sides. So it's the same as transferring 36 to the other side. It will become negative 36. So 100 plus negative 36 is 64. And since this is squared, to solve for AB, take the square root of both sides. We will get square root of 64 is 8. So this line segment AB here is 8. Another example, AB or line AB is tangent to circle O. If the measure of angle B is 37 degrees, what is the measure of angle O? Okay, the theorem states that if we have, or if this line AB is tangent, then it will form a right angle here. It's perpendicular to this radius. So if that's the case, we have 37 here, and we are asked of the angle here, of angle O. So angle B and angle O are the acute angles of this right triangle AOB here. So this is just 90 minus 37 because these two are complementary angles. So their sum is 90. So 90 minus 37 is 53. So the measure of angle O is 53 degrees. Okay, let us have another theorem. If two segments from the same exterior point are tangent to a circle, then the two segments are congruent. So this one. So if we have this illustration, PB here are two segments from the exterior point P are tangent to the circle. So these are PB and PA. So if these two segments from the same exterior point P are tangent to this circle O, then PB is congruent to PA. So BP is congruent to AP, or their measures are equal. So in the figure, PB is x plus 4, and PA is 20 minus x. Find PB. So the previous theorem states that these two are congruent segments, so their measures are equal. So x plus 4 equals 20 minus x. Solve for x. So if we will put negative x to the left side of the equation, it's going to be positive x. And if we will put positive 4 to the right side, it's going to be negative 4. So you'll put it here, and this negative x, we'll put this here. So it's going to be x plus x equals 20 minus 4. So x plus x is 2x, and 20 minus 4 is 16. Divide both sides by 2, you will get 8. So x is 8. The question is, or what we're asked to find here is PB, and PB is x plus 4. X plus 4. But we know here that x is 8, so x plus 4 is 8 plus 4. That is 12. So PB is 12. 12 centimeters. Okay, because we are given here with unit of measure centimeters. So PB is 12 centimeters. Okay, segments and rays that are contained in the tangent are also said to be tangent to the circle. So not only lines, but we can also have segments and rays. So here in this example, in this illustration, we have segment BQ tangent to circle O, and ray AP is also tangent to circle O. So secant. A secant is a line that intersects a circle at exactly 2 points. So as what you can see here, this line BC intersects the circle or circle O at points B and C at exactly 2 points. So this line is a secant to circle O. So it contains a chord of a circle. So in this case, it contains the chord BC, or line segment BC. Okay, another theorem. If two secants intersect in the exterior of a circle, then the measure of the angle formed is 1/2 the positive difference of the measures of the intercepted arcs. So the measure of angle x here, this AXB, is 1/2 the positive difference. So the bigger intercepted arc, AB, this is the intercepted arc, and another intercepted arc, CD. So the positive difference. So you have to subtract the smaller from the bigger so that you will have a positive difference. So half of the difference of these two arcs is equal to the measure of this angle AXB. Let us have an example for that. In the figure here, measure of arc AB is 110, so it's this one. And measure of arc CD is 38, it's this one. Find the measure of angle AXB. So the measure of angle AXB is half the positive difference. So half of 110 minus 38. 110 minus 38 is 72. So half of 72 is 36. So the answer is 36 degrees. So this angle here is 36 degrees. So it's one half the difference. Okay, let us have another example. In this example, measure of angle C or arc CD is 124 degrees, this one. And measure of angle X is 40, this one. So we are asked here of the measure of arc AB. So in this case, what we are asked of is one intercepted arc, the smaller intercepted arc. So we will still use the formula that the measure of the angle is half the positive difference. So the measure of angle CXD is one half the measure of arc CD minus arc AB. We know that the measure of angle CXD is 40 degrees, so replace it with 40, copy one half. Measure of angle CD or arc CD is 124, and we are asked the measure of arc AB. So we can distribute one half here, or we can multiply both sides by 2 to get rid of the fraction. So if we multiply both sides by 2, we will have 2 times 40, and then we will have 2 times 1 half of this. So 2 times 40 is 80. And 2 times 1 half will be 1. That's why we're going to be left with 124 minus measure of arc AB. And transfer measure of arc AB to the left so that you will have a positive measure. And then 80 to the right so that you're going to have 124 minus 80. And 124 minus 80 is 44. Therefore, the measure of arc AB is 44 degrees. So what we did here was we just used the formula that the measure of the angle here is half the positive difference. Okay, another theorem. If a secant and a tangent intersect in the interior of a circle, then the measure of the angle formed is one half the positive difference of the measures of the intercepted arcs. So as what you can see here, the formula is like if we have two secants, it's just that here we have a tangent. So it's still this angle is still half the positive difference of arc ACB and AD. Okay, half the positive difference of the two intercepted arcs. So it's just the same. It's just that we have here one tangent and one secant. The previous example, we have two secants. Okay, what if we're given that measure of arc AB here is 160? That's the intercepted arc of this angle X. And the measure of arc AD is 70. What's the measure of angle AXB? So the same, half the difference. So half 160 minus 70, that's half of 90, that is 45. So measure of angle AXD or AXB is 45 degrees. Another example, we are asked here of the smaller intercepted arc. Okay, measure of arc AB is 172 degrees. Measure of angle AXB is 49 degrees. Find the measure of arc AD. So same, measure of this angle here is half the difference of the two intercepted arcs. So measure of angle AXB is 1/2 measure of AB minus measure of arc AD. Measure of AXB is 49, so replace it with 49, copy 1/2. Measure of arc AB is 172 minus measure of arc AD. And then multiply both sides by 2. We will get 98 for the left side of the equation. 2 and 1/2 will cancel. We will be left with 172 minus measure of arc AD. Put this on the left and put 98 on the right. We will have measure of arc AD equals 172 minus 98. That is 74. So measure of arc AD is 74 degrees. Okay, another. Here we have a tangent dx and the secant AB intersecting at x here on the exterior of the circle. And the intercepted arcs are arc ACD, the bigger one, and the smaller one is arc BD. So we are given that the measure of arc BD is 45 degrees. Measure of angle AXD is 97 degrees. Find the measure of the bigger arc ACD. So same formula. The measure of the angle is half the difference of the two intercepted arcs. Measure of AXD is 97 here. And then that is equal to 1/2 the measure of arc ACD minus arc BD. That is 45 degrees. Multiply both sides by 2. We will have 194. 97 times 2 is 194. 1/2 times 2 will be 1. So we will be left with this here. And then put 45 to the left side. That's going to be positive 45. So 194 plus 45 is 239. So that is 239 degrees. Next theorem. If two tangents intersect in the exterior of a circle, then the measure of the angle formed is 1/2 the positive difference of the measures of the intercepted arcs. So same, half the positive difference. So the measure of this angle is half the difference of the bigger intercepted arc and the smaller intercepted arc. But in this case here, the bigger intercepted arc and the smaller intercepted arc make the whole circle. So their sum is 360 degrees. So here, measure of angle AXB is half measure of arc ACB minus arc AB. So in the figure, measure of arc ACB is 232. Find the measure of angle AXB. So the measure of arc ACB, this one, and arc AB sum up to 360 degrees. Okay, so to solve for the measure of angle AXB, that's half the positive difference of the two intercepted arcs. But the measure of arc AB can be obtained by subtracting 232 from 360 because these two arcs, ACB and AB, make the whole circle. So their sum is 360. So if one is 232, the other one must be 360 minus 232, which is 128. So this arc AB measures 128 degrees. So we can now substitute them here. So measure of angle AXB is 1/2 of 232 minus 128. And 232 minus 128 is 104. And half of 104 is 52. Oh, should be 52. 104. So it should be 52. So this should be 52, and this should also be 52. Okay, so we have an error here. Half of 104 is 52. So the answer is 52. Next, okay, here we are given with the measure of the angle, and we are asked for the two intercepted arcs, and these two are tangents. So what is the measure of uh, ACB, arc ACB, and arc AB here? So since we don't know both of them, we will represent one of them as x. So let x be the measure of arc AB, this one. Okay, so the other one must be 360 minus x because their sum is 360. So if one is x, the other one must be 360 minus x. Okay, so let's use the formula. So measure of the angle, that's 44 given, is 1/2 the positive difference. So the bigger arc here is 360 minus x. So this is the measure of the bigger arc minus the measure of the smaller arc, intercepted arc, is x. That's why we have this 360 minus x minus x. So multiply both sides by 2. We will have 44 times 2 is 88. And then this 1/2 will be canceled with 2. And copy 360, and negative x minus x will be negative 2x. And then put negative 2x to the left. It will be positive 2x. Put 88 to the right. It's going to be 360 minus 88. And that is 272. And dividing both sides by 2, x is 136. So measure of arc AB is 136. And the measure of arc ACB is 360 minus x. That's 360 minus 136. That is 224. So the measure of arc ACB is 224 degrees. So in this case, we are given with only one, the measure of the angle here. And we are asked to find the measures of the two intercepted arcs. So first, you will represent one as x, the other as 360 minus x, and you plug them in the formula together with this 44 degrees, and then solve for x. So x will give you the measure of the smaller arc, and 360 minus x for the bigger arc. Next, if two secants intersect in the interior of a circle, then the measure of an angle formed is 1/2 the sum of the measures of the arcs intercepted by the angle and its vertical angle. So here we have two secants AD and BC intersecting at x in the interior of the circle. So the measure of angle AXB is equal to 1/2 the sum of the measures of the arcs intercepted by the angle. So the arc intercepted by this angle is AB, and the angle or the arc intercepted by the vertical angle. So the vertical angle to this angle here is this one, and its intercepted arc is this. So if two secants intersect in the interior, half the sum of the two intercepted arcs is the measure of the angle. So the measure of this is half the sum of this and this. Okay, likewise, if we have this angle here, angle, let's say for example, AXC. AXC is equal to half the measure of AC plus BD. Okay, so measure of angle AXC is half the sum of the intercepted arc and the arc intercepted by the vertical angle. Okay, let us apply that theorem in this item. In the figure, measure of arc CD is 102. Measure of arc AB is 48. Find the measure of angle AXB. So it's just half the sum. So half the sum of 102 and 48. So 102 and 48, the sum is 150. Half of 150 is 75. So that is 75 degrees. Okay, how about this one? We are given here with the arc AC, but the other given is the measure of the angle here. So we are asked to find the measure of the other intercepted arc. So measure of the angle is half the sum of this AC and BD. So 78 is equal to half of 75 and this arc BD. So multiply both sides by 2. 78 times 2 is 156. So 2 and 1/2 will cancel. We will be left with 75. Put 75 to the left. That's going to be negative 75. So 156 minus 75, that is 81. So the measure of arc BD is 81 degrees. Okay, if a secant and a tangent intersect at the point of tangency, then the measure of each angle formed is 1/2 the measure of its intercepted arc. So here in this example, we have here secant XC and the tangent AB intersecting at X, which is the point of tangency. So the measure of angle AXC here, AXC, is half the measure of arc XC. So it's just half the intercepted arc. So it's like the inscribed angle, half the measure of the intercepted arc. And for the measure of BXC, angle BXC, that's half of this arc also. Half of CDX. So in the figure here, we have a measure of arc XC, this one, is 130. Find the measure of angle AXC. So AXC is just half. So half of 130 is 65. So 65 degrees. How about measure of arc CDX? CDX. CDX and XC form the whole circle. So it's just 360 minus 130. So 360 minus 130 is 230. So 230 degrees. And that is the intercepted arc of angle BXC. So the measure of angle BXC is half of 230. Half of 230 is 115. So if we have here a tangent and a secant intersecting at the point of tangency, so the angle formed is just half the intercepted arc. So that's the last theorem in this video. So I hope that you learned. So for this lesson, tangents and secants of a circle, we have several theorems to remember, and you can go back to the specific part of the video if you need to look at the examples once more. So that's it for this video. I hope that you learned. So thank you for watching, and continue to support this channel by watching the videos and subscribing. Thank you so much, and goodbye.